Good afternoon, Mindsetters, and welcome to it. Grade 11th rather. It's a beautiful afternoon. We're doing physical sciences, and as usual, I'm not alone in the studio. I'm with my teacher. How are you doing?
I'm good, and you?
I'm awesome.
Yes,
I see you. I see you in red today.
yeah, I'm right here. I'm right here. TK is here to give you top-notch learning in physical sciences. So don't worry, sit, relax. Grade 11th, it's your time now.
Yeah, you had it. It's ready to rumble. Go to our Facebook page. It's at www.facebook.com/learnextra for the latest notes and the challenge question that we're going to be posting in a minute. And of course, to stand a chance to win exciting prizes there. So just make sure that you interact with us. Throw all the questions that you might have for me and TK, and we'll make sure that we attend to them in a short while. Sir, take it away.
Well, thanks, Katlejo. And today, grade 11s, we're looking at acids and bases. Now, this is one lovely section in physical sciences. We are only today going to talk about the theory part. And of course, the next session will be looking at the practical part that is involved in acids and bases. And of course, we're looking at acids reacting with bases. So these are what, if you like, acid-base reactions. Okay, so now we're talking theory. We're talking about what are these acids and what are they, how do they behave, how do we define them, all sorts of things around them. So the aim of this lesson, or what we want to achieve in this lesson, is that at the end of the lesson, you should be able to explain the difference between acids and bases. And another thing that we want to talk about is we want to discuss, of course, these two very important theories in acids and bases. We call it the Arrhenius Theory and the Lowry-Bronsted Theory on acids and bases. We will discuss the two and get to know exactly what are they saying about acids and bases. We will also discuss, of course, to greater length, the acid-base reactions. And lastly, we will be discussing the reaction of acids, of course, with metals, or with metal oxides specifically, and also metal carbonate. So that's what we want to achieve in this lesson here. Now quickly, let's have a look at the theory on acids and bases. But before then, of course, your challenge question. What is the challenge question today? A proteolytic reaction occurs between a bicarbonate, or what we call hydrogen carbonate ion, and a bisulfate hydrogen, or what we call the hydrogen sulfate ion. One of the products formed is a carbonate ion. All right? So if one of the products formed is a carbonate ion, let's see what the questions are saying. Write down a balanced chemical equation showing how this reaction occurred. So we need a balanced equation here. And number B, label the following substances as either an acid or base. Okay, the bicarbonate ion, is it an acid or base? And of course you will still be looking at your chemical reaction that or your equation that you wrote down, the reaction between the bisulfate and the bicarbonate ion, and then you should be able to tell what substance is this? If we look at the bicarbonate ion that reacted with the bisulfate ion, is it an acid? Is it a base? That's what we want to know. The same thing on the bisulfate ion. Is it an acid or is it a base? All right. And lastly, of course, identify the acid-base conjugate pairs from the equation in A. So once you've come up with that chemical equation showing the reaction between the bisulfate ion and the bicarbonate ion, you have written that full chemical equation. Can you identify acid-base conjugate pairs from that equation? That is your challenge question. Let's meet towards the end of the lesson, and then we talk about this challenge question. Without any waste of time, let's get to the summary. Let's get to the theory about acids and bases. Right. Now, traditionally, we know, or we have learned down there in the lower grades, that acids and bases, we distinguish them making use of their physical properties. One, acids are known for their distinctive sour taste. So all acids would have that sour taste. If you are eating an orange, for example, okay, the sour taste that is there is due to the acid that is there, okay? The acetic acid that is there. All right, now, another thing that we know about acids physically is that they are corrosive in nature. They make metals to corrode. They cause rusting, okay? That's what we know about acids. Bases, on the other hand, we know them quite well by their soapy feeling, okay? When you touch basic solutions, they are soapy, all right? Okay, they make everything feel smooth, slippery, okay? They are soapy in nature. Those are bases. So that's the, if you like, the physical properties of acids and bases and how we distinguish them, making use of their physical properties. Now, coming deeper into the if you like, the microscopic science, where we get deeper into things about how acids would behave and how bases would behave. Now we come up with these theories. One, very important theory, the Arrhenius theory on acids and bases. Arrhenius was a Swedish scientist, and he introduced this acid-base reaction theory, or his acid-base theory, in the year 1887. That's quite some time back, all right? It's over a century ago. Now, according to him, an acid is a substance that will ionize to form hydrogen ions in solution, and a base is a substance that dissociates. Now, ionization and dissociation. With acids, Arrhenius see them as these substances, when you put them in water to form a solution, these substances are going to ionize. In other words, they are going to form ions. At first, you didn't have the ions, but you put them in solution, they give you ions, all right? So they ionize. But when it comes to bases, he doesn't use the word ionize. He says bases will dissociate. In other words, bases already have these ions. So all they do is to dissociate in solution to give you the hydroxide ion. So whilst acids will ionize to give you the hydrogen ions, or if you like, we will be referring to this, the hydronium ion, or what we call the oxonium ion. We will be talking about, or interchangeably, about these ions as well. So when we're talking hydrogen ion, we simply mean that. But we know that this hydrogen ion cannot exist on its own when it is in water, because with the water molecule, the H2O, you see that you've got the H there, the O, and the O there, the oxygen atoms. So what you're going to have is that this will be slightly positive. More electrons will be, the bonding electrons will be pulled towards the oxygen atoms. So the oxygen atoms are slightly negative. So the hydrogen ion doesn't exist on its own, then inside a solution. So it attaches itself to the slightly negative oxygen atom there, forming what we call the hydronium ion or the oxonium ion, the H3O+, that one. Okay, so that's why we will be using also the hydronium, the term hydronium or oxonium ion. All right, now, moving on. Let's look at some examples here. Hydrogen chloride is an acid because it ionizes in water to form hydrogen ions as follows. So you've got HCl ionizing to form H+, okay, plus the Cl minus, okay. And at first, this actually, the HCl is a gas at the beginning. So you dissolve, this is highly soluble in water, it dissolves in water and then it ionizes to give you the H+ and the Cl minus. All right, and for that reason, we classify it as an acid according to Arrhenius. On the other hand, sodium hydroxide is classified as a base because it dissociates in solution or in water to form hydroxide ions, okay, as follows. You see now you're starting with the hydronium. There is my hydronium ion here. I've written some things there. There is the sodium hydroxide base next to the hydronium ion there. It dissociates to give you sodium ion and the hydroxide ion. And that hydroxide ion is what makes it a base. Okay, so we say sodium hydroxide is a base because it dissociates in solution or in water to give us the hydroxide ions, the OH minus. We call it the hydroxide ions. It just dissociates. These ions were already there in our sodium hydroxide. Okay, so that gives us the base. So it dissolves in water or dissociates in water to give us that. Okay, and next we come to the Lowry-Bronsted theory. Now this is one theory that is so intense. It's of course a built up from Arrhenius theory. Okay, but it doesn't mean we need to throw away Arrhenius theory completely because it has got its own significance. But let's look at what Lowry-Bronsted is saying. The theory is saying about acids and bases. The two scientists, Bronsted and Lowry, okay, introduced their acid-base theories around 1923. So you can see it was quite a few years after Arrhenius has introduced his. So that means plus, I think, plus 13 years there. About 36 years after, okay, after Arrhenius theory, they came up with their acid-base theory. They define acids and bases according to how they will react with each other. So they looked at how they interact with each other chemically, these acids and bases. And depending on how they are going to interact with each other, one would be a base, the other will be an acid. And let's see how they checked them. According to them, an acid will be a substance that donates protons in an acid-base reaction. And for that reason, we call acids proton donors. So an acid is a proton donor according to them. On the other hand, they look at a base as a substance that receives protons, okay? Or it can receive a proton, just one, okay? And if there is any receiving of protons, that substance will be a base. So in short, they say a base is a proton acceptor. It accepts protons. That's what they are saying. Now, moving from this, let's look at the reactions themselves. When a reaction between water and hydrogen chloride takes place, we know that the hydrogen chloride gas is highly soluble in water. When that reaction takes place, of course this is H2O, like that. When that reaction takes place, we see the formation of the oxonium ion or the hydronium ion plus the Cl minus ions in that way. All right. In this reaction, if you check, hydrogen chloride gas is donating a proton. A proton is the hydrogen ion, the H+. Okay, that's what we call a proton, the hydrogen ion. Proton, H+ is a proton. That's what we mean by a proton, hydrogen ion. So the HCl here is donating a proton. It is donating a proton to H2O. When it donates a proton, it becomes Cl minus, whilst the H2O that has received the proton becomes H3 now, H3O plus. Okay. Right. So which one has received, has given away a proton, and which one has received? We see that HCl has donated a proton, and for that reason, HCl will be the acid in this case. Okay, so hydrogen chloride is donating a proton, and therefore it is an acid. On the other hand, the water molecule is receiving or accepting the proton from the hydrogen chloride gas. Therefore, the hydrogen chloride is an acid, whilst the water molecule is a base. Somebody will be looking at me and saying, but say, how can you say water is a base when we know water is neutral? It's neither an acid nor base. Just hang on there. This is the theory according to Lowry-Bronsted, and we need to understand it that way and apply it, okay? Another very soluble gas is ammonia, which react with water to form the ammonium ion and the hydroxide ion, okay? Now, the reaction can be represented as follows. Okay, let's look at the reaction. NH3 plus water molecule, giving us the NH4 plus ions plus the OH minus. In this reaction, water is now donating a proton. It is donating a proton to the NH3, okay? Thus, water in this case is an acid, okay? Whilst ammonium molecule is the base. So you can see now, in one instance, we're seeing water receiving a proton. So it is a base. In this instance, we're seeing water donating a proton. Donating a proton means you are an acid. So water can act as both an acid and a base. And what do we call such substances? Water is able to act as both an acid and a base. Such substance is called an ampholyte. When we have a substance acting as both acid and a base, we call such a substance an ampholyte. Acid-base conjugate pairs. These are substances that are involved in a reaction and would differ by a proton. So one has one more proton more than the other. For example, let's look at this one, HX plus NH3, and then we end up with X minus and NH4. If you look at HX and X, you would see that they differ by one proton. And therefore, for that reason, we say that these two are acid-base conjugate pairs. And because HX donated a proton, it is your acid. And X minus would receive an a proton if it was to go, if there is this reaction was to reverse, and therefore that is becoming the base. So that is an acid-base conjugate pair in that way. In the same way, NH3 and then NH4, they differ by one proton, and therefore they are acid-base conjugate pairs. Okay. Now, moving on, acid-base reactions, quickly. When you look at this one, sulfuric acid is reacting with a base, sodium hydroxide. If you have that, an acid-base reaction is called a neutralization reaction. You are going to form a salt and water. So if you have got an acid reacting with a base, we're going to form salt and water. It is the same thing here, hydrochloric acid and magnesium hydroxide. You're forming a salt and water, all right? Acid would also react with metal oxide to form the same, a salt and water. For example, hydrochloric acid with magnesium oxide, giving you magnesium chloride plus water. On the other hand, we can also have acids reacting with metal carbonates. In this case, if you've got acids reacting with metal carbonates, you're going to form salt, water, this time plus carbon dioxide, because you are having carbonates that are involved there. For example, HCl reacting with calcium carbonate, you can see you've got an acid and a carbonate. What are you forming? You're forming calcium chloride, water, and carbon dioxide. So generally you would say you are forming a salt, you're forming water, and you're forming carbon dioxide. That's when you have an acid reacting with a metal carbonate. Okay, carbon dioxide. That will be the general equation there. Now, let's stop at that point. Let me give it back to Katleho.
Thank you very much. So we're going to be going for a quick ad break, and when we come back, I'm gonna be sure to be more or less giving you more information on how you can interact with us and send your questions through and test yourself and stand a chance to win awesome prizes that we have up for grabs. And for you grade 11 and grade 12s, I have an exciting competition that will be introducing as Mindset TV to you at home. So if you are really willing to be getting a learner's license, just make sure that you do tune in for an exciting competition that I'll be giving you information on. And remember that the challenge question is up and running, and I see the questions are coming through. Just make sure that you keep them coming, and we'll make sure that we answer almost or more or less all of them when the show ends. Just in the meantime, stay tuned. Welcome back, Mindset. It's another competition that we've got up and running. As I told you when we started the show, that today we come bearing gifts. It's a beautiful competition where you stand a chance to win a Sony Xperia L, sponsored by, of course, a Sony and more or less Vodacom prices ranging from 0 to 60 bucks. So make sure that you get in touch with us on our Facebook page. You go there and then you follow the instructions there, and then you select the best teacher. Oh, it might be TK, it might be me. So you go there, you select your best teacher, and then you ask all of your friends to like it and share it, and more or less you stand a chance to win that Sony Xperia L or airtime, Vodacom airtime up to 60 bucks, rather, sponsored by Vodacom. And of course, our Casio calculator still stands. Before the show ends, I'm going to be giving you the winner, grade 11 physical science winner of our Casio calculator from next week. So make sure that if you want to be like this winner that I'm going to be announcing when the show ends, just answer the test question, the challenge question that we have there. And then if you get it right and everything else goes right, and you test yourself as many times as you can on the notes that we have on the Facebook portal as well, you'll stand a chance to win this Casio calculator. But right now, I'm going to be handing it over to TK.
Thanks, Katlego, and we're moving on now. And quickly, before we come to the questions, I've got a short summary of notes here around indicators that I want you to look at, okay? Want us to actually have a look at. Indicators in acid base, these are substances that are used to tell us whether a substance is a base or it's an acid. Now, how do they do that? They do that by detecting or telling us the pH of that particular solution. And usually, because they are indicators, they would turn to a particular color, and that color will tell us that, oh, if it turns to this color, it means the substance that we have put them in is a base. Or if they get to that other color, then it would mean that the substance that we put them in is an acid. So such are indicators. So they are chemical substances that are used to determine the pH of a solution. A substance with a pH less than 7 is called, or it will be, an acid. Acids have got pH less than 7. A substance with a pH greater than 7, that substance would be a base. And of course, if we have a substance with a pH of 7, we say that substance is neutral. Okay, we say it is neutral. Example, usually you find the pH of water, you'll find it to be 7, and we say water is neutral. And that will be a substance that is neither a base nor an acid. Indicators are usually organic dyes that will change color at specific pH levels. Examples of indicators would include, and many more others of course, bromothiamol blue, phenolphthalein, methyl orange, etc. Okay, now let's move on. Let's try to look at some questions now. We want to improve our skills, our understanding on acids and bases. Question number 1. Write down balanced chemical equations for the following reactions. 1.1. Okay, what are we looking at? We're looking at sulfuric acid reacting with calcium carbonate. Now, people, the key here is also that you need to be able to write down the correct chemical formulae of these substances so that you can be able to see how they react and be able to balance your chemical equation as well. So here you have got an acid reacting with a carbonate. If I've got an acid reacting with a carbonate, if I have an acid reacting with a carbonate, I know that the product is going to be salt plus water plus carbon dioxide. Okay, so I can write, yes, all right, so I'll have H2SO4, that is sulfuric acid, plus calcium carbonate, it's CaCO3. This will give me, the salt is going to be calcium sulfate, so it's calcium sulfate. Okay, and it's like that. I don't have a subscript for calcium because it's 2 plus and 2 minus. 2 plus from calcium, 2 minus from the sulfate ion, plus water. Okay, plus water, plus carbon dioxide. Okay, can we balance this? Do we need to balance it? Let's have a look. H2, how many H's do we have there? 2 on the right. Sulfur 1 on the right. Oxygen 4, 7. And then 4, 5, 7. So that is balanced. Calcium 1, calcium 1. Carbon 1, carbon 1. So this equation here is balanced as it is. Okay? So I don't have to put anything to balance it. It is balanced as is. So that will be it. All right. Next, nitric acid and magnesium hydroxide. This is an acid reacting with a base. I'll produce water and salt and water. So I would have nitric acid. It's what? HNO3. React with magnesium hydroxide, MgHO. Now look at this. 2 there because the OH minus is not 2 minus, it's just minus. And yet I've got Mg2 plus. Mg2 plus. So this 2 here, so this 2 here, this 2 here is the one that goes down there, and this 1 here is the one that came down there. All right, so that's how we ended up with that formula there. Okay, now plus, this gives us, okay, it's going to be a salt, so magnesium nitrate. Again, the nitrate ion is 1 minus, so the 2 for magnesium will come there, plus water. Okay, can we balance this out? H2, 3, 2 there, we have a problem. Magnesium 1, oxygen 2, oxygen 5, and then plus that, okay, this is 6 plus that, it's 7. So we rather then say, okay, let's balance the hydrogens first, or perhaps then we put a 2 there. So we've got 4 hydrogens, okay, and then we put a 2 here. Then I've got 4 hydrogens. Then that 2 also means the N, I've got a 2, then 2 there. Oxygens, I've got 6, and then I've got 8, and oxygen, I've got 8 there. So this is balanced when I put those 2 2's there. There's 1 here, there's 2 here, and that 2 there leads to my equation getting balanced. Let's have a look at the next one. Sodium hydroxide and sulfuric acid. Okay, again, an acid and a base. So what do I have here? I've got NaOH, sodium hydroxide, reacting with what? Sulfuric acid, H2SO4. All right? I'm going to produce a salt and water, but what type of a salt? I need to tell from what I have here. The sodium and the sulfate will give me the salt, and therefore the salt will be sodium sulfate. Because sodium is 1 plus and sulfate is 2 minus, I will have it like that, Na2SO4, plus the water. Okay, then balance the chemical equation. Balancing the chemical equation, I've got one sodium on the left and I've got two sodiums on the right, so I will need to put a 2 there so that the sodiums can be balanced out. Let me check the hydrogens. I've got 4 on the left, then I will need to put a 2 there so that I have 4 on the right as well. Sulfur, I've got 1 on the left, 1 on the right, I'm fine. Oxygens, now I've got 2 plus 4, 6. I've got 4 plus 2, 6 on the right, so it is then balanced. Okay, right. Moving on, question number 2. Lebu dissolves 1 gram of pure marble in 50 cubic centimeters of dilute hydrochloric acid after the marble has reacted completely with the marble, after the marble has reacted completely with the acid. Okay, let's just put it that way. It should be with the acid. All right. She uses 25 cubic centimeters of 0.1 mole cubic decimeter solution of caustic soda, sodium hydroxide, to neutralize the excess acid. Write down a balanced equation for the reaction between marble and the acid. Okay, the marble is calcium carbonate. So the acid is what? Hydrochloric acid. So you have got here calcium carbonate plus hydrochloric acid. You are going to form calcium chloride plus water plus carbon dioxide. Okay, plus carbon dioxide. Right, now balancing it out, you had calcium 1, C1, C1, I'm fine, but then I have a problem with the hydrogen already and the Cl2 and the Cl, because I've got 2 on the right, I've got 1 on the left. So I'll put a 2 there, 2 hydrogens on the left, 2 hydrogens on the right, 2 Cls on the left, 2 Cls on the right, and 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygens, 3 oxygens on the right. So I'm fine. That has been balanced. Write down a balanced equation for the reaction between the marble and the acid. Okay, so that we have done. Okay, now, so that is that answer there, this one. Now 2.2, write down a balanced equation for the reaction between caustic soda and the acid. Now caustic soda is what? It's sodium hydroxide, it's this one. And the acid is HCl. So you've got NaOH plus HCl. You're producing the salt sodium chloride plus water. Okay. Now, balancing. This is balanced, so I don't have to balance it. Balanced as it is, 1 sodium, 1 sodium, 1 oxygen, 1 oxygen, 1, 2 hydrogens, 2 hydrogens. So that's fine. Now, the next one says, calculate the number of moles of the caustic soda used to neutralize the acid. Now, let's go back to the information that is given to us. The solution of caustic soda that was there is 0.1 mole per cubic decimeter. Okay. And then what is in excess is the acid. It means the whole of sodium hydroxide has been consumed. Okay. So if I am to calculate the number of moles, I would use the equation that says concentration is number of moles over volume. Okay. Now, this student used a volume of 25 cubic centimeters to neutralize the acid. So 25 cubic centimeters, you divide that by 1,000, which will be 0.025. Okay? Or you can just, from there, just say this will be 25 by 10 to the power minus 3. That is your volume. of the base. Okay. And then if you are to calculate for it, the concentration is 0.1 equals number of moles divided by the volume, which is 25 by 10 to the power 3. Therefore, the number of moles is equal to 25 to the power 3. 25. Let me put it that side so we see that. 25 by 10 to the power minus 3 times 0.1. Okay, and what do we get? 2.5 by 10 to the power 2.5. 2.5 by 10 to the power minus 3 moles. That is the number of moles of the acid, of the caustic soda, sodium hydroxide, that has been used to neutralize the acid. So you can see that you need to go back to your knowledge of how to calculate for concentrations and understand how you can use that very important equation, C equals N over V, to calculate for the number of moles of the acid, of the base that was used here. Let me hand over to Katlego.
Thank you very much, TK. Mindsetters, remember that the notes are up and running on our Facebook page. There are links there. You just go there and then you click the link. It will direct you to our website where you can get all the notes on this subject and on this matter that we're doing today with TK. And the challenge question is also up and more or less I see people posting questions here and then. We'll make sure to attend to those questions before the show ends. And I must remind you that more or less you stand a chance to win a Casio calculator. If you just go to our Facebook portal, test yourself, and more or less the more answers that you get right, you stand a chance to win a Casio calculator. At the end of the show, I'll be announcing grade 11 Casio calculator winner from last week. And if you more or less go there and then you test yourself and you get as many questions or answers as right as possible, maybe your name will be announced next week. But in the meantime, just stay tuned. We're just going for a quick ad break. Welcome back, Mindsetters, grade 11's icon bearing gift, as I promised you. And we're going to be doing a draw now for the hashtag Get Connected competition, where you stand a chance to win a Sony Lumia. What is Sony Sony Xperia, Sony Xperia. But then in the meantime, we're going to be giving you, of course, airtime voucher worth of 55 friends to the lucky winners. So me and TK are just going to be doing the draw, and grade 11, just stay glued and cross your fingers like that for the winner.
55
friends of Vodacom.
Vodacom airtime. To who is it going? The first person. Oh,
Mamelodi Marakalala.
Marakalala, yes.
So Mamelodi Marakalala.
That's the first one. And then I need to get a second one because we also have to get to number 3. Okay, so let's see who this one is.
So the second one is Tumelo Khopane.
Tumelo Khopane, 55 airtime from Vodacom. And then, yes, do that. And then we get the third one. The third one is coming. Just hold your breath, and then we see who will be the third lucky learner here. Oh, there we go.
It's Motene Kutullo.
Motene
so
Kutullo.
All of you 3 guys
Yes,
walk away with airtime with a 55 friend. It's Motene Kutullo, Tumelo Khopane, and Mamelodi Marakalala. I'm just going to hand it over to TK.
Okay, thank you, Katlego. And then we're proceeding. We're going on with the science now, and it's back to acids and bases. We are going to our challenge question for the day, and the challenge question is this. A proteolytic reaction occurs between a bicarbonate ion and a bisulfate ion. One of the products formed is a carbonate ion. All right? Now, first question is, write a balanced chemical equation showing how this reaction occurred. So I've got a bisulfate ion. Okay? So let me just write down the bisulfate ion. That is a bisulfate ion, plus a bicarbonate ion, that. and I'm told that one of the products is a carbonate ion. That will be CO3 2 minus. Okay, so that's a carbonate ion. So what will be the other product? So I need to check carefully what has happened here for me to end up with a carbonate ion at the end. So I'm looking at this one because that is the substance that is providing my carbonate there. So this substance here has actually lost a proton. This is called a proton. This is the H plus ion. It has been lost. Where did it go? It must have come to the bisulfate ion. And if it came to the bisulfate ion, it means that instead of HSO4 minus 1 minus, it means now I've got H2SO4, and of course the whole molecule is now neutral. It's not carrying any charge, and you can see that is actually sulfuric acid. So I have had a protolytic reaction here because there has been a transfer of a proton. Now, it was one proton that was transferred, and I can say that this is a monoprotic acid that has actually donated there. But if 2 protons were donated, I would say it's a biprotic, 3 triprotic. So we can cover all, we can look at all of them, that all those acids that would actually give more than 1 proton, we call them polyprotic acids. You perhaps have come across such a term. That simply means that acid can donate more than 1 proton. So that is what I'm having there. The next one says, write down a balanced chemical equation. Okay, we have just done the balanced equation, that is number A. B says, label the following substances as either an acid or a base from the reaction. The bicarbonate ion. Now, where is the bicarbonate ion? The bicarbonate ion is this one. What has happened to the bicarbonate ion to end up giving us the CO3 2 minus? The bicarbonate ion has actually donated a proton. Okay, so it donated a proton to the bisulfate ion. And because it donated a proton to the bisulfate ion, a substance that donates a proton, according to Lowry-Bronsted theory, is an acid. Okay, so the bicarbonate ion is the acid. And this one, the bisulfate ion, received the proton. Any substance that receives a proton or accepts a proton, we call it a base, according to the Lowry-Bronsted theory. Right. Now, number C. If you look at number C, it says identify the acid-base conjugate pairs. Acid-base conjugate pairs from the equation above. Let me rewrite the equation quickly so that we can see what is happening. We have got the bisulfate ion reacting with the bicarbonate ion, and what we are producing, it's a carbonate ion plus sulfuric acid H2SO4. Now, acid-base conjugate pairs will differ by 1 proton, okay, or will differ by a proton. We can then look from left to right and see those substances that will differ by a proton. Quickly, you can see from the bicarbonate ion, moving from left to right, that the bicarbonate ion and the carbonate ion are actually distinct from each other by the fact that one is a proton less than the other. Okay, the carbonate ion is a proton less than the bicarbonate ion. So the two are acid-base conjugate pairs. And immediately we can see that this bicarbonate ion donated a proton, so it is the acid. And this one received a proton, the bisulfate received a proton. But the bicarbonate, on on donating the proton, it became the CO3 2 minus. Therefore, the CO3 2 minus become the conjugate base of HCO3 minus. So what can we then write? We can therefore say that HCO3 minus and CO3 2 minus are what? Acid-base conjugate pairs. Acid-base conjugate pairs. All right? And in the same way, we can talk to the other ones, the bisulfate, okay? Let's see what has happened with the bisulfate. The bisulfate ion received a proton, okay? When you receive a proton, you are a base. So that one is the base. Upon receiving a proton, it is a proton different to the H2SO4, okay? And that then becomes the conjugate acid of the base HSO4 minus, okay? So you would therefore say that the H2SO4 and HSO4 minus, these are what? Acid-base conjugate pairs. All right, conjugate pair. Okay, in fact, this is a pair, so not pairs. I shouldn't have said pairs there. So this is acid-base conjugate pair. All right, now, that's how you were supposed to respond to these questions here. Let's now have a look at the kind of questions you have with the little time that is remaining and see how far we can go in answering them. Katleho?
Indeed, and we're just going to be checking out questions from all of you guys, grade 11s. More or less, we have one here from, I'll tell you now. We have one here from Wendy.
Okay.
Wendy is asking, I want to ask a question. I didn't really get what an acid and a metal oxide produce. So could you please help me out there?
Oh, okay. Acid and a metal oxide. Acid plus a metal oxide will produce, metal oxide will give us, just like bases, okay? It will give us a salt and water, okay? So when I have HCl plus potassium nitrate, for example. Okay, no, it must be an metal oxide, okay? So let's say I've got potassium oxide. What am I going to produce? I would produce potassium chloride plus what? Plus water. Okay, so if we have got a metal oxide reacting with an acid, you produce a salt and water. Of course, you can go ahead and balance this equation here. You would see you would need a 2 there and a 2 there. All right, so that is how they react, and that's what you will get. Oh, time is up. Well,
time is indeed up. Thank you very much, sir, for that. I hope you answered Wendy there. And more or less, just make sure that you get to our Facebook portal for the latest notes on what we are studying today. And if you are 16 like me or over 16 like me, and then you are more or less applying for a learner's license and you're in grade 10 or grade 12, just make sure that you stay tuned to Mindset TV, and we'll be making sure that we bring you information on how you can enter our competition, which is an awesome, exciting competition starting on the 15th of September on this channel. But then do stay tuned to our shows on grade 11 and grade 12, because between the shows we'll be bringing you information on how you can be part of this brilliant competition that we've got lined up. Just stay tuned. We'll be back from the ad break.